Hi everybody, my name is Wayne Lording. I represent the Cloverdale Group, and today I'm just here to chat to you about anti-drone systems. Just a little bit about myself. I've worked with Defence for many years, so I've been a electronic warfare and surveillance specialist, and I've been a drone pilot for many years, as well as a helicopter and fixed-wing pilot. So I've got a lot of information I can share with you, but wanted to talk about obviously a very hot topic at the moment, which is the actual anti-drone systems. We've got a system here that's available in Australia to actually look at, and I'll just run through some of the technology now and why we actually need anti-drone systems. Okay, so with anti-drone systems, we've got one that will actually control the sky. It's modular. It's a military-grade system. It's a multi-sensor system, which I'll go into in a moment as to why that's very important. And this anti-drone system has been around for some time and deployed right across the world in many cases. So very interesting topic, and it's very much a topic that's to be looked at in the civilian world as well as the military world as well. So I'll just head to the next slide. So why do we need an anti-drone system? Well, as you know, at the moment, anti-drones and drones are becoming such a huge thing in the world, very popular. They're very popular for obviously things such as filming and collecting data and evidence, but also in the military world as well, they're using them as weapons. So we've got some huge issues with drones. I've had a lot of conversations with military people in talking about what's happening in different parts of the world and how terrorists are actually using drones at this point in time. So again, it is a very hot topic at the moment. The drone numbers are just going through the roof, so we need to look at how we actually manage them. If you think about different events that go on around the world, like concerts and presidents driving around, drones can be certainly a threat. So we need to control the skies. If you look at the drone numbers in Australia and all over the world, drones have just sold way beyond what most manufacturers thought that they would. You're looking at around about 6.4 million drones in 2015. By 2021, we're looking at around about 67 million drones. So how do we control that? How do we control the skies? So I'm going to talk about how we do that. Okay, now there are different anti-drone systems out there today, but from my background, one of the things that I've had a lot to do with is actual radar technology and RF sensors. And to actually grab a drone, which is a very small device, and it can also be a very big device, you need something that is a very sound technology out there today. And we're going to look at particularly radars and RF sensors and why they are the best way to actually track drones when flying across the skies. Okay, how to select the most viable technology? Well, a lot of my background with the military being radars, there is huge benefits to radars. There is RF sensors out there, but there's limitations to the RF sensors. But something else too that people don't really think about when you're looking at anti-drone technology is the fact that with cameras and video processing and sound, that's another way to actually pick up a drone in flying through. So, you can actually pick up the drone on the radar system, but through our camera systems, you can actually pinpoint the drone and actually look at what kind of drone it is. But also too, they do make noise, so therefore you've got an extra sensor there as well to help you. And I'll talk about the Wi-Fi sensors there in a moment too. Okay, let's have a look at why different technology works best. Okay, well, RF sensors, they're very good for picking up RF-based drones only. Now, there's a lot of drones that obviously work on 4 and 5G mobile technologies today, which are invisible to the RF sensors. The RF sensors give a bunch of information on different transmissions, so there can be different transmissions in the sky or around the place, and the RF sensors can pick them up. Wi-Fi routing as well. There's obviously a whole heap of Wi-Fi out there that could potentially pick up, could be picked up by different systems, and it could be a false drone detection. So we've really got to look at, what you're wanting to achieve. Now, when you're looking at a drone, it can be a very small drone, it can be drone swarming, or it can be a very large drone. So we want to make sure that what we're picking up in the sky is a real drone. And is it a threat? Is it friend or foe? So again, I'll just go to the next slide and talk about the different technologies. Okay, so basically what we're going to talk about here is this is a 3D MIMO radar. I'm just going to put it in layman's terms here. A 3D radar is basically like a fly. If you go to swat a fly, you can pretty much see that, that fly will see you at no matter what angle out there. Whereas some of the other radars that are out there are a bit like the human eye, and the human eye needs to move from left to right to actually see exactly what's going on. So our technology is actually a multi-input, multi-output radar, which is better known as a MIMO radar. And that fly type technology gives you a bit of an analogy how it actually works. Okay, so with the ANSI radar, again, as I spoke about before, you're looking at a human type eye movement where you're scanning. You have to scan across left to right to actually pick up an object. Whereas with a MIMO radar, you're looking at almost 360 degrees with an overlap, and you're looking at the objects out there like you're looking at a fly's looking for a fly swat to come on. So I hope in those layman terms, that's what I'm trying to explain here. There's a bit of a graphic there and how it all works. Okay, so the most effective option out there at the moment is obviously the 3D radar, as I mentioned a moment ago, and with that 360-degree swoop, you've got a 360-degree pattern that you can actually look at and detect, and I'll talk about how we can potentially destroy that as well. Now, when I've been talking to military organisations, there's a couple of things that that definitely need to occur, and that is that one, you can destroy a drone. Number two, you can take control and make it land. Or number three, when you need to destroy it, not only with a shooting it down, but with some kind of electromagnetic pulse. But there's another thing that you can do too, and that is to actually jam the signal of the drone too, which I'll go into. But with this particular APS drone system, we've been deploying it and testing our systems in every environment. We've had them seaside, we've had them, as you can see, on scissor lifts there. We've got them in military applications. We've got them sitting at airports and right through Europe as well. So the intense temperatures are down to minus 20, minus 30, up to plus 50 degrees. And this system really works. Now, one of the other things that people ask me too, is it portable? Yes, it is. This anti-drone system can be mounted to a trailer or to a ute. So it's very portable, which is great to drive it into a rock concert, for instance, or, if the Queen or the President of the United States is driving down in a motor car, this anti-drone system can actually follow it and detect. Just to show you some of the different bits and pieces here that that we've been able to do with this system, the APS radar system, we've had flights up to 3,000 metres, between 3,000 and 5,000 metres were conducted at 150 metres above the ground, and we've been able to track that drone movement massively, and that was with a DJI Phantom 4, which is a very, very small drone. So you can imagine going to some of the bigger drones, most definitely it's a lot more effective. As I mentioned a moment ago too, we've got visual sensors there. Some of those visual sensors, such as cameras, you can point, tilt, zoom, and you can look straight into that drone system, into that actual drone, and see what type of drone it actually is. We've got acoustic sensors, which can actually pick up sound. And then we've got Wi-Fi sensors as well, which can actually disconnect the talk between a particular controller and the drone itself. Just on this next slide there, this is actually an animation. Some of the older drone detection systems, that you can see birds flying and that type of thing, and different movements, whereas over on the left-hand side, there is actually one particular drone flying, and that radar will pick up that drone very well. Some of our software, some of the Skyview software, this is some of the web-based software that we use to actually control the drone or the anti-drone system. I can certainly talk to you more about that and how that particular system does fit into other anti-missile systems and other weaponry systems as well through API integration. One thing that I will touch on very quickly, and this is much more a military application, is that we can actually jam all sorts of different frequencies and different drone frequencies with this particular system up to 1,000 metres. So we can actually take over and land a drone or completely jam it. Again, that's something for more discussion. And that's pretty much it. If you do have any more questions, please come back to me at my email address there or my phone number, and I'm happy to discuss it more. Thanks very much for your time.